Hi, welcome to my video on double angle formula for sine. This is video number 2, and in this video we're going to find the value of the sine of 2 theta. Number 1, find the value of sine 2 theta. So we have an A part here. The angle A is acute, and the cos of angle A is 3/5. So angle A is acute means the angle is between 0 and 90. So if I draw my diagram here, draw the circle. Angle A is this far is in quadrant 1, so we draw a terminal arm, drop a perpendicular to the x-axis, and what we have is this is the reference angle here. So cos is adjacent over hypotenuse in this right triangle. So the adjacent is a 3, which is the x, and the hypotenuse is 5, which is the radius of the circle. Now doing the Pythagorean, c squared equals a squared plus b squared on the right triangle. 5 is the hypotenuse, 3 is this side, and we need to find what this side is. So let's call that the b, or we can call it the y. So that's 25, 9, b squared. So b squared, 25 minus 9 is 16. So b is plus or minus the square root of 16. So b is plus or minus 4. And since it's in quadrant 1, y going up is a 4. So that means that we have the sine of angle A. Sine is opposite over hypotenuse, so it's 4/5. So we need to work out the sine of 2A, which is 2 sine A cos A. And sine A is 4/5. Cos A is 3/5. When you multiply that, it's over 1. So your denominator is 25. And 8 times 3 is 24. So that's the value of sine 2A. And again, we're using the unit circle, or this is not a unit circle. This is not a unit circle. We're just using the circle, which has a radius of 3. And I find it better to do that than to go with 1/5 or 3/5 here and a 1 and work out this to be 4/5. I find this faster. Let's look at B. Pi less than A less than 3 pi over 2, and the sine of A is a negative 12 over 13. Well, pi is 180. Pi is 180, so pi over 2, 180 divided by 2 is 90. 3 times 90 is 270. So as in the first one, we draw our circle, and it's between 180 and 270. So we start from here, rotate around. So that means that angle A is somewhere in here. So there's the rotation. Draw your terminal arm, drop a perpendicular to the x-axis. And sine is opposite over hypotenuse in this diagram. So the hypotenuse is 13. Opposite is a negative 12. And we have to find what this side is by Pythagorean property. C squared is a squared plus b squared. So hypotenuse is 13. A is negative 12 squared plus b squared. So 169, 144. And 169 subtract 144 is a 25. So b is plus or minus the square root of 25. So b is plus or minus 5. So this side right here is moving to the left as x is negative, so that's a negative 5. So that means the cos of angle A is adjacent over hypotenuse, so it's a negative 5 over 13. Cos is the x over the radius, or it's the adjacent over the hypotenuse. So we need the sine of 2a, which is 2 sine a cos a. And sine a is negative 12 over 13. Cos a is negative 5 over 13. The 2 is over 1, multiply, and we can multiply the numerators. That's a negative times a negative is positive, and that's a 10 times 12. 2 times 5 is 10, so 12 times 10 is 120, and 13 times 13 is 169. And 169 is 13 times 13. 13 is primed, so this number is can't reduce in. So 120 over 169 can't reduce down. So that's the value. And let's continue. Now we try to do something a little bit different. Find the value of the sine of 2a again, and we have example C. Notice this time we have an inverse function. So this is tan to the negative 1 of this number. So that gives us angle A. So in tan, when we have a tan is defined from 90 to 0 to 90. That's where the angle is. So from negative 90 to 90, this number is negative. From 0 to 90, the number is positive. So that means that this angle, A, is from 0 to negative 90. We can use our calculator and turn the calculator on and do inverse tan of negative 1. Inverse tan of negative 1, we get negative 45. The angle is negative 45. So what happens, if you draw a diagram like this, and tan is a negative 1, tan is the opposite over the adjacent, so that's negative 1 over 1. So, but we're in a negative angle, so we're in this quadrant here. So this rotation here is, and opposite is the negative 1 over adjacent, which is 1. So that means because these two sides are equal, this hypotenuse is root 2. And notice, because these two are equal, that means this angle is 45. So that means the rotation here is negative 45 degrees. But we really don't need that. We just know that the angle is 45. We can draw the triangle. And that means that the sine of angle A is opposite over hypotenuse. So that's negative 1 over root 2. And that works out to be negative root 2 over 2. And the cos of angle A is adjacent over hypotenuse, which is 1 over root 2. And you rationalize it, you'll get root 2 over 2. So when we put it together, the sine of 2a is 2 sine A cos A. So sine A is negative root 2 over 2. Cos A is root 2 over 2. And we multiply that out is over 1. 2 cancels out here. Negative times a positive is a negative. Root 2 times root 2 is root 4, which is 2. And 1 times 2 is 2. So that comes out to be negative 1. And that's the value. Another way that we could do this is that if we came up with the angle to be negative 45, that means that the sine of 2a, if we worked out the angle to be negative 45 here, which we did, so we could go sine of negative 45. That's the sine of negative 90 degrees. And on the unit circle, right here, this is negative 90 is right here. So this point right here on this circle the sine of 90, well, let's take here, but on the unit circle, if we have a unit circle whose radius is 1, so this is 1, 0, so this point right here is 0, negative 1. So the sine on the unit circle of negative 90, which is the y, is negative 1. Just another way you can do. And if you did it here, then this would be negative 1 because sine would be of the negative 90 would be this radius, this would be right here, this distance here would be a root 2, 0. And if you did this circle, you got a root 2, comma 0. And so this point here is 0, negative root 2. And so sine would be the opposite over the hypotenuse. And so in terms of 90, it would be the y over the hypotenuse, so it's a negative root 2 over root 2, which is negative 1. Again, it's easier to use the unit circle. Number 2, evaluate the sine of 2 times cos to the negative 1 of negative 4/5. So we have a cos to the negative 1 on negative 4/5. Cos is defined inverse cos of the negative 1. That's an inverse of a number. This is an inverse of this number. We get an angle. So this cos is defined by, it's from 0 to 180. So 0 to 90, cos is positive. From 90 to 180 is negative. So that means that we draw this diagram. The cos of negative 4/5 is between 90 and 180. So that means it's rotated around here. Terminal arm, perpendicular. Now you might say, well, how do I know it's that? Well, it's from 0 to 180, and I know it's positive between 0 and 90 and negative. But if you use your calculator and just use your calculator and go inverse cos of negative 4 divided by 5, it gives you 143 degrees. So I know that if I got a 143 degrees, this is 143. This is the reference angle right here. This is the reference angle in this corner. So cos is the adjacent over the hypotenuse, or the x over the radius. Cos is the adjacent, so that's negative 4 over the hypotenuse of 5. And we work out the Pythagorean again. C squared is a squared plus b squared. So we got 5 squared, negative 4 squared, and b squared, which could be the y, 25, 16, and b squared, 25 minus 16 is 9. B squared is plus or minus the square root of 9. So b is plus or minus 3. And in this case, this is the 3 and the y going up. So we want b is the positive 3. Okay, so now we have, this is the angle that's right here. So we got the sine, if we call this angle rotating here A, so that's angle A. So that's, twice sine A cos A. And the sine is, and I didn't write out what sine was, but let's write it down. Let's put it here. If cos is a negative 4/5, then the sine of angle A is opposite over hypotenuse. So the sine of angle A is the same as the sine of this reference angle in quadrant 2. So it's 3/5. So sine is 3 over 5. Cos is the negative 4 over 5 over 1. So multiply 2 times 3 is 6, times negative 4 is negative 24 over 25. Again, in all this math, we always back on the skills. Again, these are inverses, and these inverses were done in my unit on trig number 2, which I tried to explain how to work these out. But I used my calculator to verify that the angle was, we said 143, but it was in the second quadrant. Because I knew this, I knew the angles between 90 and 180, which was here. I could draw my triangle and work. I'm not using my calculator when I do it this way. But again, I verified by using my calculator to be 143. And I didn't need the angle. I just need to know that it was angle A. I called it angle A, just that's what we're trying to find. So this rotation is the angle A, and it helps explain. And that brings us to the end of this video. If you like my video, click the like button, click the subscribe button if you wish. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.